Proving trig identities. All right, so we've gone through the process of simplifying trig expressions using trig identities. We've done verifying the proofs of trig identities. Now we're going to actually provide those proofs for ourselves. And what I want to say is that this process looks a lot different when you do it on ALEKS versus when you do it on paper. So I want to talk you through the kind of thought process that you'll need to know for doing this on ALEKS. And then I will have a separate video talking about the ALEKS tool itself, because it is a little bit funny in how it wants its answers given to it. What we're going to do is very similar to what we did when we were verifying, except for we're going to be providing the statements and the rules instead of just the rules like we did in the previous video. The same identities that we've been working with all along. And again, the idea is move from one side to the other. So take this equation, this expression right here, use identities and algebra, turn it into secant. That is the goal. So let me just start it that way, right? Let's say this guy right here, this is our goal. Our goal is to end up with secant x. With ALEKS, it's always going to start by using the left-hand side. So we'll just start, LHS stands for left-hand side. I'm going to start by just writing that down. Cosine x times 1 plus tangent squared x. And here's the thing. I'm going to make these look really, really easy. And it's because I've been doing math for a very long time. I've been teaching for over a decade. I've been doing math for much longer than I've been teaching. I have a very attuned brain to this type of math. Not to mention, I've given this lecture many, many times, and I know how these problems are worked through. It will appear to be very straightforward, almost algorithmic as I do these problems, but the process itself is oftentimes full of wrong roads taken. I just in class yesterday started doing one of these problems on this worksheet, and it led us down quite a messy road. We didn't have time to finish the problem. But sometimes you go down roads and it just doesn't turn out, and you have to start over again. This happens and is supposed to happen. You're supposed to choose a road, follow it, go as long as you can, and if it doesn't look like it's going to where it needs to go, you start over again and you try again down a different pathway. This is something that every person who does these problems goes through. All right, so just there's my disclaimer. I'm going to make it look easy, but it really isn't that easy. It's my superpower that I've developed over many, many years of doing this. All right, so here's what my brain sees when I look at this first. I see 1 plus tangent squared x, and my brain says, is that a Pythagorean identity? So let's look up here. Do we see 1 plus tangent squared x? We do. That's equal to secant squared x. I'm just going to make a note here that 1 plus tangent squared x is equal to secant squared x. So I'm going to make that replacement. We're going to leave cosine x alone. And then we're changing 1 plus tangent squared x into secant squared x. The rule that we used was a Pythagorean. We used a Pythagorean identity. So I'm going to be listing the rules over here on the right side. All right, the goal is for this to turn into secant x. And so I know some canceling needs to happen because that's not there yet. So I'm going to leave cosine x alone, but I know that secant x and cosine are soulmates, so something fun should happen here. I'm going to turn secant squared into 1 over cosine squared. When I do so, I have used a reciprocal identity. You can see that secant is 1 over cosine right over there. From here, one of the cosines cancels. So I have 1 over cosine x left over. I did algebra to simplify there. That was algebra to simplify. And then 1 over cosine is the same thing as secant x. And that is a reciprocal identity. My goal was to make it into secant, was to turn it into secant. I have done so. I have secant. This is the right-hand side. and I put a little smiley face. This is the important part. You put a little smiley face because you did the proof correctly. And that's that. That's a proof. I proved it. I proved it, and I wrote down which rule I used every step of the way. Let's try again. So we have secant x minus cosine x. When in doubt, when I'm looking at something like this and I'm in doubt, my intuition, if I don't see a Pythagorean identity, is always going to be the same, and it's going to be turn everything into sines and cosines. Our goal is for this to turn into sine x tangent x. That's the goal. We're going to start with the left-hand side, which is secant x minus cosine x. And my thought process here is, hey, there's no Pythagorean. Let's turn everything into sines and cosines. So secant, I'm going to turn into 1 over cosine x minus cosine x. That is a reciprocal identity. And then I'm looking at this and I think, well, I know that there's just one term over here, so maybe there's some kind of combining of fractions that I can do here to make this one fraction. And I could do that if I had a common denominator. So what I'm going to do with the 1 over cosine x is leave it alone. And then for cosine x, I'm going to multiply by cosine x over cosine x so that it gets a denominator of cosine x. All right. And I'm going to write this as 1 over cosine x minus cosine x times cosine x. That's cosine squared x divided by cosine. Both of these steps here, these were both algebra. And they could be done in one step. They don't need to be written out separately. But I wanted to write out what was happening there. And indeed, the next step too also could be included in all that. Let me kind of condense this together since I'm taking up a lot of space. The next step will also just be algebra, and it's rewriting this as one fraction, 1 minus cosine squared x divided by cosine x. All of these steps right here from, let's see, let's make a better curly brace than that. All of those steps there, those are all algebra. 1 minus cosine squared x. Now, this guy, that one right there, that is a Pythagorean identity. That 1 minus cosine squared x is equal to sine squared. So I'm going to write this as sine squared x divided by cosine x. That was using a Pythagorean identity. I'm going to pull this right up to here. Our goal is for it to be sine x, tangent x. So I'm going to take one of those sine x that was on top and pull it off to the side. And I would be left with sine x divided by cosine x. That is just doing algebra. I'll just write ALG for algebra. And then sine x divided by cosine x. This guy right here, that is tangent x. So this is sine x times tangent x. And that is by a quotient. A quotient identity. And that is our right-hand side. That is what we wanted. That is our goal. And so we are obligated to put a smiley face. Yay, we did it. All right, let's do more. Let's do more. You might want to take a moment and try. Although I will say there is a trick. There is a trick to this one. So maybe we should talk about the trick. So I'm looking at this next one. Sine x divided by 1 plus cosine x is equal to cosecant x minus cotan x. And I know that, again, we know our goal. Here's our goal right there. We're starting with our left-hand side, which is sine x divided by 1 plus cosine x. Most of my usual tactics here are not going to work well. So I would typically, if there's a Pythagorean involved, then I would do that, but there's nothing squared. If there was anything that could be rewritten with sine or cosine, I would do that, but we don't have any of those. So you're going to need a tricky trick that you wouldn't have thought of on your own. You're only going to think of it now because I'm bringing it up, and that's okay. I'm putting this into your toolbox so that you can use it in the future, but it's not something that you're expected to know on your own or to have thought of on your own. When you end up in a situation like this, and especially when you see something being added or subtracted in the denominator, not just multiplication, but this is 1 plus cosine x, there's a trick. Multiply the numerator and denominator of that fraction by the conjugate of the denominator. Multiply num and denom by conjugate of the denom. Now, when you think of conjugates, you might be thinking of like radicals and their conjugates, or you might be thinking of complex numbers and complex conjugates. And you might not think that conjugates apply in this scenario, but really the conjugate is just going to be swapping this plus sign to a minus sign. So what it will be doing is multiplying the numerator and denominator by 1 minus cosine x, 1 minus cosine x instead of 1 plus cosine x. This is just algebra. I haven't done anything here, just algebra. I technically should have left the first step alone, but you know, it's fine. This is algebra. What you do down here, you create a difference of squares, and I'm gonna just multiply this over here and then delete it. So just to kind of prove what's happening, you don't need to write this down if you're someone who's writing down notes. I'm going to delete it. But I want to show this multiplication. So you multiply the first ones together, right? You get 1. 1 times 1 is 1. Multiply first outer. So 1 times negative cosine x, that's negative cosine x. Cosine x times 1, that's plus cosine x. And cosine x times negative cosine x is minus cosine squared x. So you can see the negative cosine x and positive cosine x, those just end up canceling each other, and you end up with 1 minus cosine squared x. So the middle terms cancel. It's a big deal. Middle terms cancel, and that's why we chose to do the conjugate, so that the middle terms would cancel. So this turns into, I'm going to leave the numerator alone. I'm just going to leave it factored out like this. You could always distribute and see what happens. You can always do that. But I'm just going to FOIL out the denominator to begin with. 1 minus cosine squared x. Well, I look at that and my brain says, hooray, 1 minus cosine squared x is great because that is sine squared x. By the way, move that down there. By the way, the step that happened here was just FOILing, which is algebra, to get from the first line, to get from here to here. That was algebra. Sine x times 1 minus cosine x, all divided by, this will become sine squared x. This was a Pythagorean identity. From here, I know one of these signs will cancel, so I'm left with 1 minus cosine x divided by sine x. That's algebra. And I notice that my final answer is supposed to be cosecant x minus cotangent x. So it's supposed to be two different terms. So one thing I can do, if you have, and this is kind of basic fraction math, but I'm just going to write it here, a minus b over c, you can give them both the denominator. That's a over c minus b over c. The idea here being like, let's say we had 3 minus 1 divided by 5. So 2 over 5, really, right? This is the same thing as 3 over 5 minus 1 over 5. So 3/5 minus 1/5, that leaves you with 2/5. So that's kind of like that connection here. When you split it up, you give the denominator to both of them. I'll delete this part. So this turns into 1 over sine x minus cosine x over sine x. Again, algebra. Now, if you were doing this on paper, it would really just kind of be one step to the final answer. However, because you'll be doing these on ALEKS, ALEKS is a little bit particular about how these are entered. And you're going to look at this and say, well, that right there is cosecant, that's cotangent, done, right? And it should be that easy. However, those are different rules, different identities that are used to get from one step to the next. So you have to write those steps out separately so that you can appropriately identify which rule was used. 1 over sine x is cosecant x minus cosine x over sine x. For that, we used a reciprocal rule. The reciprocal rule, I'll just write res for reciprocal identity. And then we can do cosine x divided by sine x, which is a quotient identity. That's equal to cotan x. And that is a quotient. And look at it, that was what we wanted. That's our right-hand side. Left-hand side turned into the right-hand side, and we put a smiley face. All right, and that's that one. Now, this next one I did in class, and we did the conjugate first, and things turned really messy. So let's pretend that we went down a really messy path. I think I can actually pull that up. Where is it? Let's see. Oh man, oh, it's gonna be hard to find. That's okay. But it got a little messy when we did the conjugate first here. So my intuition when I see tangents and cotangents anyway is to turn them into sines and cosines first, simplify, and then go from there. So that's what I'm going to do. I'm going to start with the left-hand side, which is tangent x minus cotangent x divided by tangent x plus cotangent x. The goal is to turn it into 2 sine squared x minus 1. I'm going to start by changing tangents into sines over cosines and cotangents into cosines over sines. So let's do these tangents will turn into sine over cosine. These are cosine over sine. So we have sine x divided by cosine x minus cosine x divided by sine x divided all by the same thing but a plus sign. Same thing but a plus. All right. I have used on this step, well, I guess I should have. It's down here, huh? On this step, I used quotient. I can do this in one step because it was quotient identities for both of those. I now want to simplify this complex fraction. And you have options on how you do this, depending on your familiarity with fractions. My intuition here is to multiply the numerator and denominator of the big fraction by sine x cosine x, and then distribute it. It's a little bit difficult to explain the algebra that ends up happening there. So another option we have here is doing a cross we can simplify the numerator into one fraction and the denominator into one fraction. You multiply, and then you put whatever sign is here, and then you multiply, and then these two multiply in the denominator. So the way that would look, sine x times sine x is sine squared x. And then it's a minus sign in the middle, minus cosine x times cosine x, so cosine squared x, all divided by these two multiplied together, cosine x, sine x. All right, so we've simplified, that's the very top part of the fraction. And then, right, and maybe I should kind of highlight here, right? That's this whole thing is this, and this down here will be what goes down here. It'll be the same thing, except for a plus in the middle. It'll be sine squared x plus cosine squared x divided by cosine x sine x. We have done just algebra here, algebra. I see now that both of them have denominators of cosine x sine x, and so I'm going to multiply the numerator and denominator of the big fraction by cosine x sine x, which you might remember as my intuition initially. This will have the same effect. So that cancels this denominator. So that's it. And then this denominator and that denominator get canceled. And whoops, that is a thick marker. On the top, we're left with sine squared minus cosine squared. On the bottom, we're left with sine squared plus cosine squared. And all we have done here is algebra. I know sine squared plus cosine squared is a Pythagorean identity. That's our most common one. They are equal to 1. Okay. Sine squared x plus cosine squared x is equal to 1. So this becomes sine squared x minus cosine squared x divided by 1. We did that by a Pythagorean identity. And of course, that's just sine squared x. Oh, well, now we're not done yet. We're not done yet. We need it to be 2 sine squared x minus 1. So I'm down to sine squared x minus cosine squared x, but I need to do something more here. And I know I want sine squared, so I better work on converting this cosine squared into something more useful. If I look up here, I know that cosine squared x is equal to 1 minus sine squared x. So I'm going to just try making that replacement. So the sine squared x I had originally comes down, minus, this will be 1 minus, and I'm using parentheses, those are important here, 1 minus sine squared x. That was a Pythagorean identity. I'm going to distribute that negative sign to both of these. So I get sine squared x minus 1, then the negative turns to a positive, negative, negative, plus sine squared x. This was algebra, we just distributed. And so I have sine squared x plus sine squared x, that's 2 sine squared x minus 1, and that was just algebra. And that is our other side. That's what we wanted. That's our right-hand side. Let me do a smiley face. That's it. So yes, it's a bit of work on this one. However, the conjugate makes it even worse. It gets even messier than that. And sometimes you do just go down the wrong path, and that's okay on these, and it's expected. It's part of the puzzling of it. Whenever you start to feel frustrated, like the algebra is not algebraing, just start all over. There's no harm in starting over, or at least going back to like step 2 or 3 to see if there's something salvageable there. All right, so in our next video, we're going to talk about the even and odd properties of trig functions and do some proving of identities using those properties. And that'll be it for this section. So I'll see you in that next video. Bye.